Hey guys, welcome to another video. So in this video, I'll be talking about the aerodynamic center of an aerofoil. Now, this is considered to be a slightly complicated topic, but I think it is very simple if you actually understand it in the right sense of it. Now, when it comes to all these pressures acting, I said that lift is created because of high pressure below and low pressure above. When all these forces are acting, there would be something called as a moment. Now, when you go back to your class 8th, 9th and 10th physics, do you remember what is moment? I'll read out the definition to you. The moment of a force is a measure of its tendency to cause a body to rotate about a specific point or axis. So it's nothing but whenever there's all these forces involved, there would be always a moment or a rotational force involved about a certain point. Now, when it comes to let's say an aerofoil, you should remember that let's take three points into account, right? You remember the center of pressure, which we learned the last time. You remember the leading edge and you remember the trailing edge. Now let's name or abbreviate it as the leading point, or the as A. We can the leading point of the aerofoil can be abbreviated as point A. The trailing edge can be abbreviated as point P, and the center of pressure can be abbreviated as point CP. Now AC here, or like if you can see, I've drawn this diagram. AC here is the aerodynamic center. So this is the aerodynamic center, right? Now what I want to explain is, first of all, let's remember what is moment. Moment is nothing but a turning force, right? Or when all these pressures and forces are acting on the aerofoil, there'll always be a turning force, like I said. Now, what is the formula of moment? The formula of moment is force into distance. If I know you all remember this, it's force into distance. I'm just reminding you. Okay. Now, when it comes to this particular case, the distance here is between A and CP, or the leading edge and the center of pressure, and there's also a distance which we take into account, which is B and center of pressure. Now, when it comes to the turning moment at the leading edge, they're basically saying that in this particular case, a turning effect of the lift force around 3 points A, B and AC is being considered, which is the leading edge, trailing edge and the aerodynamic center. So at the end of it, I'll link it to what is aerodynamic center. So I want to say that the first thing is that when you consider the turning moment or the turning motion or the turning force that is there at the leading edge, it's a downward or an anti-clockwise turning force is being created at the leading edge. Now at the trailing edge, a clockwise moment or a clockwise force is being created. In both cases, what is happening is the nose is being pushed down and the tail is being pushed down, right? Now, what happens is, eventually what will happen is that all these forces cancel out each other. Now, as there's this anti-clockwise pressure or force being applied on the leading edge, what happens? The leading edge is forced to push down, okay? And that's not a good thing for us, because angle of attack always has to be upwards for a lift to happen. But then what happens is that there's also force being applied on the trailing edge, which is downwards, right? So downwards, again, if this goes down, this will come up, right? And again, the angle of attack is being increased. So more or less what is happening is that both the turning motions of these two points is cancelling out each other in one way or the other. Now, what they are, I'll read out to you what they are trying to say. First, consider the turning motion of lift force about point A. So point A is basically this point that we spoke about, and they're saying that the turning moment is anti-clockwise or nose down in direction, which we spoke about. The size of the moment depends on the product of the lift force and the distance between A and the center of pressure. So the lift force is this. So lift force and this distance is basically, again, if you remember, force into distance is your moment. So and you also remember that center of pressure keeps moving forward. The center of pressure will keep moving forward as the angle of attack increases. So this distance will keep decreasing as the angle of attack decreases. But this distance will keep increasing, right, as the angle of attack is increased, because this center of pressure moves forward towards the leading edge. So what is happening is, as this force decreases or increases, the other force increases, and finally all these turning motions are cancelled out in one way or the other. Now, as complicated as it may sound, finally what you have to understand that aerodynamic center is the point at which all these forces or all these moments are zero, right? So basically the engineers use this point so that they can basically calculate this point so that they can efficiently build an aerofoil and also calculate its efficiency, coefficient of lift, and etc. all these good things. So that was the aerodynamic center. Finally, what you take out of it is where all the moments are equal to zero is where your aerodynamic center is, right? And if this question is coming in your exam, where is all your moments or all your turning forces zero, it is your aerodynamic center. So center of pressure was where all the forces are acting through an aerofoil, and aerodynamic center is where all your moments are equal to zero, right? So that is it for your exams, and I hope I could explain something to you. I mean, I'm trying my best, but yeah, this is what I can do. In any case, if you have any doubts, please feel free to ask me through Instagram or wherever you want to. Happy landings, guys. Cheers. Take care.